So, hi everybody, welcome to today's SpecFlow stream. I'm Andreas Willich, Community Manager of SpecFlow, and today in today's stream we are writing plugins for SpecFlow. Yeah, SpecFlow has plugins for code generation and at build time and also at runtime. But before we go to that, quick reminder, all of our project, all of the code that we produce is in our separate GitHub project on our SpecFlow SS organization streaming project. There we have all the code we worked before there, and all of this stream is recorded, and all of the recordings we upload to our YouTube channel.
Hello and welcome to this 5-part.
Thanks, Bas. You can see, we uploaded to our YouTube channel. We have a separate playlist also with all the recordings of the past streams, and also this will be uploaded. If you're seeing this now live at Twitch, please go to the YouTube channel and subscribe to get notification when we upload the recording. If you see this currently on YouTube, follow us on Twitch, on Twitch TV/SpecFlow, to get notification when we are streaming. Good. Let's get started. So first a little bit explanation what plugins are. So I already said there are two types of plugins in SpecFlow, one for runtime and one for the generator. The runtime plugins are for adjusting what is happening at runtime in SpecFlow. You can what can you do? SpecFlow plus Living Doc needs a runtime plugin to work. Now our friends at Test Project have a runtime plugin that combines Test Project with SpecFlow, and you can adjust all what's happening at runtime. You can adjust in a runtime plugin. Generator plugin. These are the plugins that are executed when you create the code behind files of feature files. So when you have here the feature file, we always have this feature.cs file, and with generator plugins you can adjust what is generated. One good example is, we put this up recently in our documentation, is to have you can make a decorator that translates your tags, your tags that you have like this, to an attribute in your .NET code. We recently made we wrote the documentation for this, and I can't find it. Perhaps it's not yet merged. I have to check. Cool. So let's get started writing. Let's start with a runtime plugin, and then that's the easier one, and then we go to the generator plugin. So Visual Studio 2019, as usual. Let's create a new project. In this case we want a class library, and we want all project types. So let it search. Still not faster. They didn't fix it yet. Okay, done. And we take .NET Standard Class Library for C#. Yes. Let's move this into our streaming projects. This is our streaming runtime plugin. So, and now it's already the first important thing is runtime plugins have to end, the assembly have to end with .SpecFlow plugin. That SpecFlow can recognize this and load it as a plugin. So let's add this already to the project name, but the solution name is only streaming plugin. And we remove this. Let's quickly check first if we are in the right branch. We are on main. Let's make a quick fetch. Yes, good. Let's make a branch streaming plugins. So let's create this. So first thing, the name of the assembly is important. Without that, SpecFlow doesn't load it. So you can this class. So we are ready. We can let's remove this class file. We don't need this. Go away. Here, so we have our project, and the first thing we need to do is so runtime plugin have to target not only .NET Standard 2.0 like we selected in the wizard, but also target .NET 4.6.1. Theoretical .NET Framework 4.6.1 supports .NET Standard 2.0, but we have there are assembly loading problems, and that's why also the SpecFlow runtime is targeting 4.6.1 and .NET Standard 2.0. And to target multiple frameworks, that is easy. You open the CS profile, and for empty class library, it's not much here. And what you need to do is you need to change target framework to target frameworks, and then you can here make a semicolon separated list with frameworks, .NET frameworks you want to support. And in that case, we add 4.6.1 and save this. Yeah, sometimes Visual Studio wants them to reload the project when you change this. And when you have now a look at the dependencies, you have both .NET frameworks. Let's see if we can build this without any code. Yes, and you see already we have now two outputs, put files. One thing I want to add, and I think we should add this to the documentation, is because of 4.6.1 .NET Framework 4.6.1, compiling on Linux or Mac build agent is without some little extra not possible. Let's add this. So let's have a quick look how we're doing this. So build props to build for .NET. This is this. So let's copy it here. For that you can build .NET Framework 4.6.1 on non-Windows machines, you need these reference assemblies, this Microsoft Framework reference assemblies NuGet package, which has a lot of dependencies, and because of that, you can build it on Linux and Mac OS. So let's add this to the documentation also. I'll show you also in this stream how you can edit the SpecFlow documentation. So first let's quickly switch to a new branch. Let's update this. So update doc/update plugin documentation. So short excursus to how to work with the plugin documentation of SpecFlow. All the documentation is in the docs folder, and you write it in Markdown. Let's open Visual Studio, and there's everything is written in nearly everything is written in Markdown, and you can also generate it locally. How you need some dependencies for that, and you find this all in the contributing Markdown. What is installed and what you need to install and run the documentation. I've already installed this, so I only need to switch to the docs folder, and then I can execute mage HTML. And when this is finished, you have locally some the generated files. One of the Visual Studios is, let's close this Visual Studio. So now we've finished. So if you go now here in docs, you have here underscore build HTML index, and you have now here a local build of the documentation. So let's adjust this, add this to the plugin documentation. Here it's integrate, no, it's not, it's extend SpecFlow, extend plugins, create a runtime plugin. Yeah. Create a runtime plugin. Oh, I wanted to go. Yeah, because I see one thing we will change, we will add with the new SpecFlow 3.6 version, which will be released probably next Monday, so the 25th of January, is that you can also write plugins in your own test assembly, so you don't need a separate project, but it's not yet released, so we need still a separate project for that. Plugins. So plugins, runtime plugins, creator, runtime plugin, class library. Let's put it at the end. Let's put it at the end. Plugin developer example, plugin developer. Yeah, we have a plugin developer channel which is not on Gitter anymore. So let's fix this also. Tips and tricks. Building plugins on non-Windows machines for building.NET 4.6.1 projects on non-Windows machines. The .NET framework reference assemblies are needed. You can add them with following package reference to your project. And let's put markdown and okay, not anymore here. So let's format this quickly. And when we build this again, we get, takes a little bit, and done. So let's open it here, and then we have here now in plugins, you see here tips and tricks, and then we have here our stuff. So let's commit this. Add tip for referencing.NET framework reference assemblies. So, and the other thing is we will also change is the developer channel. This is not true anymore because we are not anymore on GitHub. We have on Discord. We have set up plugin developers here, and there's the link missing. And this would be let's quickly get the link. So I can't show you this. Discord. Contribute. No, plugin developer link. Copy. And here. Yeah, go SpecFlow, join plugin development on Discord. I have it now closed. I think so. Yeah. And there, me and the team and me are there, and you can ask us questions about writing plugins. Good. This is correct. Cool. So this is here with the link, so we can also connect this. Replace Gitter with Discord. Good, let's continue writing the plugin. So we have now set up the project. Let's create the plugin. So, and the main entry point is you need a class. So this is our streaming runtime plugin. And what you need to do is we need a class, and then for runtime plugins we need only SpecFlow as a dependency. So let's get SpecFlow. add this. Yes. SpecFlow dependencies and what we can do now. So runtime plugins need to implement the runtime plugin interface. Let's implement this. Don't throw an exception. Then they need to be public. They need to be public. Then we have to put then we need to add an assembly level attribute here. This has to be outside the namespace. There's a runtime plugin type of streaming runtime plugin. And that's it. And now, why is there? Okay, let's call it. Now, if SpecFlow would find this assembly, it calls the initialize method, and from there we can continue. And yeah, let's create a test project that we can see that this plugin is working. So new project. This time we can use the SpecFlow project. This is our streaming plugin test project. Core 3.1. Let's say XUnit this time, Fluent, great. So we have it here. And we should be able to set here a breakpoint. And let's have a look at the test explorer. Let's build this. And also for completeness, let's also target this. No, let's make it first run and then let's complete. So we have the one test. Let's run this. Nothing will happen. I should do debugging. Not only run, but yeah, okay, it's failing. It's failing because it's pending. XUnit doesn't know about this, but when we, let's say, debug this, our runtime plugin isn't called because there is no dependency between them yet. So we get only here the pending exceptions. So, but when we now add a dependency here to our runtime plugin, and let's rebuild this. What should happen? Okay, there's a version of okay, we need to update the we need to update here. Let's update both. 355 3 5 14 and this was now there are more updates. We update all of them. Okay, let's clean this up. So let's build it again. So everything works, and when we have now a look in the project directory, we should see in the bin debug net core app, we should now see there our streaming plugin here. And when we debug now the feature, we should hit our breakpoint. Yes, and we're here. And this is all what's needed. So with the reference now we get the exception, yes. But the plugin needs to be in the output directory, and there's SpecFlow searches for it, and from that it loads and go on. Cool. So now that we are called, so let's commit this all. Working empty runtime plugin. So, but how do we adjust now stuff in SpecFlow? So, important parameters here, the runtime plugin events. When you have a look at this runtime plugin events, we have not the methods, we can't hide them, but we have here the different events. Where you can then, adjust different registrations. So SpecFlow is heavily using dependency injection within, and what you can do is you can simply register your own implementation for some interfaces, and depending on which level they are, you need to do it in a different way. So we have somewhere container available containers and registration. This is perhaps a little bit outdated, but not that bad. Registration of different interfaces where they are registered. But you can, that's if you want to change the behavior of SpecFlow. But you can simply also add there your own classes and resolve them there. So what do we want to override? No, we don't want to override. We have also something new, which is something new. Didn't I save this before? I saw the line. We have also something new in SpecFlow where you can react on the different events of the runtime. So before test run and the scenario start and so. How was this called? This is give me a second. Where is this? Environment access, following infrastructure. Execution engine. Test run start. Fire events. This one. Get hook container. it's the Runtime Plugin Test Execution Lifecycle Events. That's a mouthful. Yes, this class. So there we have different events for where we have also hooks before test run, before feature, before scenario, before step, and helper methods. And with that you can also now react on in runtime plugins for that. What you need to do is where is this dependent? Where is this registered? Default. It's registered in the default in the global container. Cool. So we can where can we can get them in global dependencies. Yeah, global dependencies. We add our method for that, and here in the args we get the object container, and from this one we can resolve our runtime plugin test execution lifecycle events. Let's save this as a variable, and there we can now say not on call, but we have here the events, and we want to get called before the scenario, and now simply add also an event here. That's okay. And what do we want to do? We get here in the args again the object container where we can then resolve. Let's do something different. Not the before scenario. We get the after step. And what we can do now here is we get from the object container we can resolve again stuff we know from SpecFlow. So we can get the scenario context, and yeah, that's the scenario context, and we can now do if scenario context scenario info scenario execution status doesn't equal to okay. We have an error. In the steps, in the step. I can react on this. So let's simply make here a breakpoint. Cool. And when we run this now in debug, the interface is called. So if we register our event somewhere, then in the call stack, this is called from the infrastructure. We get the class, register our event here, and then after some time, okay, we have here the exception. And now our after step is called. We get the scenario context and have a six from pending. Yeah, it's not okay. It's pending. And we have also other information here, like scenario info with the title, also some arguments. We have the tags here, test error, execution status. what you need. So and with that you could write your own reports, submit it to whatever system you want, but this is, you can here with that hook into the life cycle and get stuff out to your systems, what you have. Write your own file, write the test message, direct connect it to Teams. As usual, your imagination is the limit. So add example how to react on hook live events. Cool. Good. This is a runtime plugin. That's the easy one. Let's make now a generator plugin. That's a little bit harder. But we start again with a new project. Let's make again a class library. And this is our streaming generator plugin, and it does also, no, I think it doesn't need to be called. No, the name of the generator plugin isn't necessary. It doesn't need to be a SpecFlow plugin, but for consistency, I would also recommend to make it SpecFlow plugin. So class here. So again, we also need, let's take over the reference assemblies that we need. So what else do we need to do with the project? So we need, this is now a little bit different. Generator plugins can't be net standard 2.0. Theoretically, I think they're now we changed it. Yeah, they can be theoretically, but again, assembly loading issues. Generator plugin should target net for 7.1. No, also for 6.1. We pinned everything to .NET 4.6 because it's the earliest supported version of .NET from Microsoft, and the other thing we need is .NET Core App 2.1. So, why do we need this? And here it gets complicated. There is a generator plugins are called when you compile your SpecFlow plugin. And compiled is done via MS Build, the build system. And there are two versions of MS Build. There is the .NET Framework, the MS Build version that runs on .NET Framework. That is the one that's used by Visual Studio and is called per msbuild.exe. That can't be found now. Open command line, developer command prompt, msbuild. That's the .NET Framework version of msbuild. And for that, we need to compile the generator plugin for .NET 4.6.1 for full framework. And that's the one. And there is also a .NET Core version of MS Build. If you use .NET Build, then the .NET Core version of MS Build is used, and for that you need to compile your generator plugin for .NET Core 2.1 at the moment, because .NET Build runs at .NET Core 2.1. So that's the reason you have to target this. And these two MS Build versions are now is something that will makes this all a little bit complicated, because we need to do additional stuff. Before we go to that, let's set up the rest of the project here correct. So what we need is a dependency on a different NuGet package. So we have this SpecFlow custom plugin NuGet package, and this is needed to write generator extension generator plugins for SpecFlow. Let's add this to the project, because this includes all the generator classes. The normal SpecFlow package only has the runtime parts. So you have here packages, and it contains a lot of dependencies and has some additional libraries, assemblies included. So, and now we can add a new class here. That's our streaming generator plugin. And like the runtime plugin, we need to, but for the generator, we need to implement the generator plugin. Implement this, let's prove the initialize, and then we have again on assembly level generator plugin type of streaming generator plugin. Same as for the runtime plugin. And now we have set this up. So now it gets a little bit complicated. Let's have the use case that you don't want to ship it via NuGet package. This is only now done for your one project. You need it only from your one project, and this is done. So for that we need to adjust write a little bit MS Build magic. What we need is we need to tell SpecFlow that it should load the generator plugin. So this is not like the runtime plugin, it's simply done automatically, but for generator plugin you need to give SpecFlow, you have to say SpecFlow that you want to load this generator plugin. And this is done via MS Build, because everything happens for that in MS Build time. And you say this with here. This is the example. So we have a MS Build item group, SpecFlow generator, blah blah, is the list, and there you say what you need to include. And this is, in that case, is we want to include the stuff from here, from the output. Here from the output for the standard 2. So how do we make this possible? So we need now some stuff. So there is an ms build, ms build. No, the VR default is where this file is. So we go one folder up. So we have to now relative path. We are here. We get one folder up. We go to test project. We go to bin debug. No, this was the wrong one up. The generator plugin bin debug. Let's take 1461 and take, where is the streaming plugin? So shift right click, copy as path here, and then we can, no, we don't need the escapist, we can remove here a lot of stuff. Streaming project done. Item group, why it is quickly, it is closed. No, I didn't save it. Okay, once again, we need this item group. We need this path, we don't want to escape it. And this is Double save, close. Why not the what? I'm in the wrong. Include here. So let's reload everything. So I was in the wrong project file. So the test project. So if this item group, we say, okay, load this one. So we can make this a little bit nicer. Let's make a property group. Let's call it path to our generator plugin. And let's move this here in this property, and then we can use it here and that way. So, and to see that this is working, so let's make here a debugger.launch debugger, no, only one G, launch, to start a debugger. And what we need also is that the build order is correct. We need to add a project dependency to the generator plugin. But as we don't need the assembly, we can say here in the properties that this is a reference output assembly false. No. What means it that it's only a build time dependency and not a normal dependency as the runtime plugin here. So when we build this and it works, debugger is launched. Let's take a new instance. And yeah, yeah, we are in our generator plugin, debugger launch, very well. Cool. So our generator plugin is working. It's working from Visual Studio. When we go now in the command line here and say .NET build, then it is also working. Okay. Cool. Yeah. On Windows it can load the 461 .NET Framework 461 assemblies. What doesn't work on Linux. Yeah. Now we have there is some file logging problems. Let's see if this are gone. Make a rebuild. I think this was because of the debugger. And now the debugger again. We have to remove this launch here to make it easier for us. So, once again. Cool. Works. So, works on Windows. So we need to do a little bit adjustment here. So the first thing is we can, and it only works for debug. The first thing is we need to replace this debug with configuration. This is the MS build property where you have debug or release depending on what you have. So, and then the other thing we want to adjust is this not .NET 461. Because of the different MS build runtimes, what I told you. So, what you will need to do, let's make also this, move this into a property. Generator TFM, target framework moniker. This is the generator TFM. And now we have it here. What we could do now in MS Build, and we can make ifs, and we can detect if we are in a .NET Framework version of MS Build or in a .NET Core version of MS Build. And I can't remember this correct. Yeah, there we have it. So let's paste this and adjust this. So that's there, and this is 461 and cool. So what this does is this property groups has now a condition, and if the MS Build runtime type equals core, that's so .NET. When you use .NET Build, it's using the .NET Core App 2.1 TFM and the .NET Core plugin, and when you're not in the core, we use the .NET 461 version of the plugin. Cool. So how we can show you that this is. Let's build it so this works. I have here. Let's make ifs. So if net 461 else and if. So that's a console write line .NET framework, and this is a console. Can here switch to .NET Core app console write line .NET Core. So we don't see this here. Let's add again a debugger.launch that we can see this when we now build this. Now what has happened is we only built a generator plugin, so Visual Studio didn't recognize that we need also to build the project, so let's build it on our own. Okay, build it means there isn't changes. Let's make a rebuild that it gets the trigger, and we see, okay, the debugger launch is here, and we should see URMNS build exe, and we should let's make it different. Let's close this. Now let's swap the order. Let's swap the order, and then we can step through that we see this what is happening. Let's rebuild this again. New instance. So, debugger launch, and when we step through, we come to, within full framework, come to console, right line add framework, and add. Cool. So let's end this. No, we don't want to save this. And then we go now here and use .NET build. And say new instance. Yeah, again, debugger don't launch. We are in .NET exe, but we are in the .NET Core console right line. Yes. This was only for showing you that with a lot of different assemblies, you don't need this normally in your day-to-day practice. You don't need in your runtime plugin to make these differentiations. This works. And so let's commit this. Working empty generator plugin. So what can we do now in the generator? So as previously said, you can adjust how the code behind files are generated, like adding additional attributes on the class. What attributes could we? Let's do this. What could we add here? No, that's our own. What is an what as we are using XUnit, what XUnit attributes are xunit.org? I think it's XUnit, no, xunit.net. What attributes are available? Running parallel sharing. There was a comparing fact, trait, theory. We can, let's add a simple hard-coded trait. It's a little bit. No property. It's what can we do? Assertions. XUnit attributes. Let's put on all. We want to have let's make it simple. Let's work. We have here category my tag, and so and let's give all without doing anything a trait attribute, a hard-coded trait attribute, no matter what. So we use the decorator for that. So quickly check, did we already merge the documentation for it? We should have merged this already. How to write and use a decorator. Where did we put this? Extend decorators. Plugin, extend decorators. There it is. So decorators is, yeah, it's easy. That's some code that you can decorate all your different methods here in a decorator. Words are hard. Add additional attributes to your code behind. So let's create a class here. So streaming decorator, and we got the code from the documentation. So we need to adjust this a little bit. So we have let's adjust the name. So what do we have here? So no, let's start from the beginning. So we have the iTest method tag decorator. We implement this, and there come a lot of stuff gets implemented. So we have a can decorate from, priority, remove process tags, and apply other decorators for process tags. We don't need to implement. We don't need their default. So can decorate from. That's the method. If you can now, if you want to decorate this, in our example here, we test if a tag matches a special tag. But in our case, we always want that it gets decorated. So we say return true. And decorate from is how should it be decorated. And in that case, we want a custom attribute here. So let's get this code. So we are working on code DOM. We get here. So first we get the tag name. Then we have the generation context and the test method. This is from how we generate the code. And we use code DOM for this everything, and to add, there's on the test methods, custom attributes, add the attribute, and you have here to use code DOM to specify this. And in that case, we don't want to have any unit framework attribute. We want to have this XUnit trait attribute. We don't want this. We want the XUnit trait attribute as name. That's the type name. And then we have code attribute argument. this is in parameter. This is the first argument and the second argument. And this is, both are of type string. The first is category fix and then our value. So code reference expression, we want a system string and the field, and that's the field name. I think this is only category. And then we can add a new code attribute with a new code. We can copy, we should be able to copy this whole. And this is also stream and the string, and this is streaming. And that should it be. No, that's only the decorator, but we still have to connect the decorator together. And for that, we need to register the decorator. And yeah, we have this to do in the register dependencies event. As with the runtime plugins, we have for the generator plugin events, there are different events, a little less because not so much there. Make a registration there, and then you need to register your. You need to register the decorator. So the event access E object container register type. So we register our streaming decorator with as this interface, and then you have to give the registration a name because there could be multiple decorators there. And this is our streaming decorator. So let's build this and let's. So the generator plugin is built. Let's run the. Let's rebuild the plugin, the test project, and we got some errors. Because we generated this incorrect. But you see, it was. Our code is called, but we did our reflection code wrong because this is not a code field reference. This is a code argument base cast. Not the default, it's a value. Variable declaration. It's let's have a look at the SpecFlow source, and what we're using Kotum is hard. So generator, test generator. No, this is not Kotum. It's I always search for this class. It's part generate test file code. Feature chain. Setup class. Test cleaner, create unit tests. Create unit test. Create test. Method. Setup test method. Yeah, it's decorate test method. Oh, that's our decorators. There's the categories. Okay, set property, add attribute. That's a CodeDOM helper, our own CodeDOM helper. So, primitive expression. Primitive expression. Category. And code attribute declaration, code attribute, yes. So let's no. Too much. This is this, this is this, this is this, this is this. What is the problem? It's easier. So this is category, and then it's this. This was the code attribute argument. Attribute type. And we have only one argument with this. So let's see if this worked. So everything is built. Okay, once again. Category equals category. Not. No. We have one attribute that is. We have the declaration. No, this is declaration attribute argument. The argument is new attribute value is trait attribute attribute type. And then we have all the values. And this is no. Trait attribute. Maximum trait attribute. This should be. I'm a little bit confused. So attribute type. That's that we have, and then we have a list of attribute arguments with primitive expressions. So and this is where is the method? Trait name value. Yeah, so it's one attribute argument. This is a new code primitive expression. Yes, but this is a this is one, so let's insert this again, and then that's params, and this is streaming. So, do we have it now? There were no errors. Yes, finally. And when we have now look at the test explorer, we have now here also a hard-coded streaming trait without changing anything in the feature file. And then we remove here my tag and rebuild this. We only have, why is there other ones now? That's interesting. Did we find a bug in SpecFlow? Oh, she should be here. We found a bug in... Okay, decorators are only called if there is at least one tag there. I didn't know that, and I think we should change this. Interesting. So there were a test. I saw that. What is navigate back? Art. There were some registry tests. Yeah, shoot the group test method. Area tag. Yeah. So, interesting. If I add this some tag to trigger decorators, yeah, now we have both. Okay, interesting. Let's that was the wrong Visual Studio. Let's add a test and see if this is really wrong. I think we should change this behavior. SpecFlow. Good. That's also first, finding a bug during a stream. So we found already there is a Decorator registry tests class. Okay, let's Visual Studio load. Get something to drink in the meantime. So, mouse. Okay, Visual Studio is frozen. No, it's still loading. Sorry. So, Decorator registry tests. So, let's check first that they are all green. Hello. So we have some classes, helper classes here. Then we have the should decorate test class. Okay, should decorate test class but not applicable. Okay, then you see should remove multiple decorators. Priority for feature tag should not decorate test method for feature tag. What is this? Never. So it's building now, it's running. So everything is green. So question is, do we have there an existing test? No, let's add a. So we want to test this registry decorate test method and we'll verify that our stuff is called. So let's make public void should decorate when no tags are set. So we have arrange act assert. So we have this. We want this. So we need this registry and call the decorate test method. So we create get a test a registry with this call. This okay makes a normal registry. So registry decorate test method. So then we have a general. You need a generation context with a string tag. What's this tag? This is create any document with tag, string tag. Get tags. Tags is equals null. We get an empty list. That's cool. So going back to our test, we want here null. We want no tags at all. Then we have the code member method. That we don't need. That's the method where we would add this tag that we don't need. Then we have here a list of tags. This is also null. And then we get out var unprocessed tags. So we don't need this stuff. So then we want to verify our mock. So we want to get our mock, and then we want that our test method decorator mock. We verify that the decorate from is called we don't generation don't matter which generation context doesn't matter, and the code member method is also this any code member method. And yeah, verifies. It's called cool. So, and we need the test method. We need to set up that D can decorate from. It don't matter. It's always the parameters doesn't matter. We want that it's always returning true. Code member method returns true. So we have a mock. We set up that it can decorate true. We have a registry. We should register our we need to register our mock. Static decorator, but that's is it. Register the decorator, then the decorator registry is called. We call the method for the registry. This registry should then at the end go here and call the can decorate. Did we implement the wrong? Tag decorator. We need a test method decorator. I used the wrong. There are two kinds of decorators. Yeah, then the registration doesn't work. It's a test method decorator. So that worked. So let's remove this one. Used the wrong interface, implemented the wrong interface. Okay, wasn't also not aware of this. So there is a I test method decorator, and there is a I test method tag decorator. And the tag decorator is for translating tags to attributes, and if you have hard-coded static attributes, then you need that I test method decorator. Okay, cool. Yeah, that's also a way to test method decorator. Okay. We don't need the test. But we should document this. Because I think we didn't do that. Creative implements interface method. Okay, we have it here. I should have read it. But let's describe here what Decorator Andi. My test method decorator is for adding static for decorating a method. Always I test method tag decorator is for decorating a method, and it is depending on at least one method. Sorry. And tags are being evolved is for decorating is for always, is for decorating and at least one tag are called only if at least one tag is on the scenario. Is called always. If the scenario has at least one tag. Good. How does this look like? Where's that's local one, cool, decorators. Yeah, correct. Stuff. Cool. Now we have a working decorator example. Yeah, and that's how you create plugins, runtime plugins and generator plugins. If you're all in the same solution, it's rather easy. If you want to ship it via NuGet package, it's get a little bit more complicated. Because you have to put you need to have some adjustments for to generating the NuGet package, but you need additional more MS Build magic that the stuff is happening. We documented this all here in the documentation, what you need to do additionally. We'll split this plugin, this documentation, once for NuGet stuff and once for the when you use it in your own solution. Yeah, there will be some changes to the plugin documentation. I saw this today, but it's correct. So follow it. You can follow it, and everything is working. So, and this takes more time than we have left. Let's end it for today. Thanks again for attending. Code will go up on the streaming projects, GitHub repo. Recording of this session today will go up on YouTube in the next days. it always takes some time to process these long videos. If you're watching this on YouTube, please subscribe if you haven't, and follow us on Twitch TV/SpecFlow to get notifications when we are streaming, and for YouTube when we upload new YouTube videos. And yeah, if you're all of the recordings and other cool videos about SpecFlow are on our YouTube channel. Yeah, subscribe there, like the videos, and
Hello and welcome.
yeah, and have a buzz. And yeah, I hope you see us next time. Next time will be a funny topic if everything works. No spoilers yet, but perhaps I will tease something on Twitter the next days. So have a nice and good rest of the day, and see you next time. Bye.